Hello, today I'm going to go ahead and go over the answer key for the homework quiz. I'm going to work through it, right? And hopefully this will answer any questions that you guys had on the homework quiz and help you also prepare for next week's assessment. So here we go. So the first question says, what is the center and the radius of the given circle, or of the circle given by the equation? So the first thing we have to do is we have to make sure that we get the equation in standard form. So the standard form of a circle is x minus h squared plus y minus k squared equals r squared. So I need to get this into standard form. So the first thing I'm going to do is you're going to add 6 to both sides. Right? So that's going to give you 5x squared plus 5y squared equals 125. The next thing I need to do is get rid of the 5. Right? So I have a 5 in front of my x and a 5 in front of my y. So there's no leading coefficients in front of these terms, so I need to make sure that they're 1. So I'm going to divide every term by 5 to get the leading coefficient to be 1. So then now that gives me x squared plus y squared equals 25. So that means that my r squared is 25, which means that my radius is going to be the square root of 25, which is 5. So now I know my radius is 5. The center, since there is no h and no k, my center is at 0, 0. So let's move on to the ellipse. So remember, the ellipse has two different formulas. So the main formula is going to be the same as a circle. It's going to be your x minus h quantity squared plus y minus k quantity squared, but now it's going to equal 1, right? So it has to equal 1 like this does. And then now you have denominators. So you have your a squared and your b squared. So remember, with an ellipse, your a is always the larger term. So a has to be bigger than b. So remember, your a always is a vertice. Your b values are always a co-vertice, and your c values are always a foci. Okay, so let's go ahead and work through this. So we have x minus h, right? So my h is 2. Y minus k, so that means that in order to make this a plus, that would have had to have been a minus 1, right? So this is my k value. So y minus a negative 1 would give me a y plus 1. So my k value is negative 1. So that's my center. So since the a value has to be the larger value, then I see that 25 is my a squared. Right, so I say a squared equals 25. So that means a equals plus or minus 5. The square root of 25. So your b value is your smaller one, so b squared is 16. And then b is the square root of 16, or plus or minus 4. So remember, vertices are an a, co-vertices are a b, and foci are a c. So I look at my vertice. To find the coordinates of my vertice, I'm going to add and subtract 5 units to the y coordinate of my center. Since the 25 comes from underneath the y, I'm going to add that to the y coordinate of the center. So we're going to say 5, or negative 1 plus 5 gives me 4, and the x coordinate stays the same. So then to get the other one, I have my x coordinate of 2, and then I'm going to subtract 5 from negative 1. So negative 1 minus 5 gives me negative 6. I'm going to do the same thing for the co-vertices, but I'm going to add and subtract the b value, and I'm going to do that to the x coordinate, right, of your center. So we say b, or 2, plus your b value of 4 gives me 6 comma negative 1, so the y value doesn't change. And then now I go to 2, and I'm going to subtract 4, which gives me negative 2, and your y value doesn't change. So the foci has to lie on the major axes. The major axes, remember, goes, your major your major axis goes with your A value. Your minor axis goes with your B value. So the foci has to lie on the major axis, so it's going to have to be on the same line as these vertices. So that means that my x value is going to stay the same as my vertices, right? So I am going to have to find my c value. So to do that, we're going to use that formula c squared equals a squared minus b squared. So c squared is going to equal 25 minus 16, which equals 9. So that means c equals plus or minus 3. So I'm going to add and subtract 3 units to the y coordinate of my center. So negative 1 plus 3 is 2. Negative 1 minus 3 is negative 4. And then now we can go over here and plot it on our graph. So we're going to go to 2, go over 2 and down 1, plot my center. And then from the center we can go back here. So it's another way to double check to make sure that we got this stuff right. So from my center, I should be going on the x-axis, left and right, the square root of this number, right? So from here, I'm going to add and subtract 4 units on the x-axis. So here we go. 1, 2, 3, 4. That's adding 4. We'll go back to our center and subtract 4. 1, 2, 3, 4. There we go. And these coordinate points should match my covertices. All right, so I have 6, so 6, negative 1, yep. And then negative 2, negative 1. Yes, so I've got my covertices right. So then now we go here to get the vertices, your major axes. You're going to go up and down on the y, since this is under y, go up and down 5 units. 1, 2, 3, 4, 5. All right, so pause your point there. And then you go down 5 from the center. 1, 2, 3, 4, 5. And if we look, that should be 2, 4, and it is, and 2, negative 6, and it is. So now I have my vertices plotted correctly. So I can go ahead and draw my ellipse, right? And it should be longer, since it's a y, it should be longer on the y than it is on the x. And it's not the best ellipse, but yes, it is longer. So now I can plot my foci. So 2, 2. Go over 2, up 2, and it says 2, negative 4, so 2 and go down 4. So there are my foci, and they should be 3 units away from my center, so I could check that. 1, 2, 3 it is, 1, 2, 3 it is. So now that makes, so by graphing it and looking at it, I can see I got all of these points correct. This matches that. All right, so let's move on to the next one. So the next one says that if they want you to write an equation for the ellipse given just the vertices and the foci. So again, we know the vertices is an A, the foci gives me my C. So, and we can use that equation right here, c squared equals a squared minus b squared, to find my b value. So the first thing we need to do is find the center. So just like our picture here, we know that the center has to lie halfway between my covertices and my vertices, right? So that means that my center has to be halfway between these 2 points. So to figure out what halfway is, I can use the midpoint formula, right? And I can add, you can say 7 plus negative 3 divided by 2, and 1 plus 1 divided by 2. And that will give me my center. So 7 minus 3 is 4, 4 divided by 2 is 2, 1 plus 1 is 2, divided by 2 is 1. So now I know that my center, right? My center is at 2, 1. So I need to figure out what my A value and my B value is so that I can actually write the equation. So I know that if my center is at 2, 1, right, if that is my center, then my vertice, if I write that underneath here, 7, 1, my vertice I know is my major axis, so I can look to see, well, what is the distance from the center to the vertice point, right, to one of the vertice points. So if I notice here, I go from 2 to 5, I notice that is a change of 5 units, right? So my A value, and it's a change in my X, my A value is 5 units away. And I could do the same thing. I could say from 2 to -3. So 2 to -3 is 5 units as well. So it doesn't matter which, if you use the first one or the second one. All right, so that gives me my A value. So then I know, okay, well, if I have my centers at 2, 1, and I look at my foci, or one of them is called the focus. So if I look at one of the focuses, so 5, 1, and I look at the distance here, the distance from 2 to 5 is 3. So that means C equals 3, right? So now I can use that formula right here to figure out what my B value is. So this formula says C squared, so 3 squared is 9, equals A squared, which is 25, minus B squared. We can solve this algebraically to find B squared. So I'm going to subtract 25. That gives me -16 equals -B squared. Divide by -1. So that gives me B squared equals 16. So that means B equals 4, right? So now I can write my equation. So remember, your equation for an ellipse, that you write it as x minus your h. So my h is 2, so x minus 2 quantity squared, right? Then plus y minus your k, so y minus 1 quantity squared. And I know that's going to equal 1. So now let's talk about what goes in the denominator. So over here you notice I wrote this as the change in x. So I knew that this changed in the x coordinate. So that means this A value needs to come underneath my x term. So we know that this bottom term is A squared. So this is going to be 5 squared, or 25. Then my B value we just found to be 4. So the B value is going to come underneath my y. So 4 squared is 16. So the equation is x minus 2 quantity squared over 25 plus y minus k quantity squared over 16 equals 1. And then you can go ahead and go over here and graph that. Right, you can graph your center at 2, 1, and then on the x you're going to go back and forth 5 units, so 2, 5, go back 2, 5, you're going to go up 4, 2, 4, 2, 4, and then you're going to draw your ellipse. There you go. All right, let's look at the back side. So our last problem. So here we go. So this one says, graph the equation of a hyperbola and identify the center, the vertices, and the co-vertices. So we're going to do the center the same way. So the center is your h and k. So your center is going to be 2, -1, right? Because it's plus 1, so it's -1. So now for a hyperbola. For a hyperbola, your A value has to be your first term. So my A value here is 25. Or I should say A squared is 25. Because remember, this is over A squared and B squared. So A squared equals 25. So A equals plus or minus 5. B squared equals 16. So B equals plus or minus 4. All right. So we find our vertices the same way. We're going to add and subtract, right, 5 to the x coordinate. So since this was the change in the x, right, we're going to add and subtract 5 to the x coordinate of my center. So I'm going to say 2 plus 5 gives me 7, -1. And then 2 minus 5 is -3, -1. Your co-vertices, you're going to add and subtract 4 units to your y coordinate. So that's going to give you 2, 3 and 2, -5. All right. So now we're going to go over here and we're going to plot those points. So we have 2, -1, and then let's see, we went over 5, we went back 5. Then from here we went up 4, you notice this is like the same one that we just did, kind of. Oops, sorry, my screen went to sleep. Alright, so go back to center, go down 4. Alright, so now here's where it's different. So instead of going ahead and drawing an ellipse, right, we have to draw a hyperbola, so we're going to draw those, we're going to make our imaginary rectangle from these vertices and co-vertices. So I'm going to go through, right, and make, I know this is hard to see, make my imaginary box going through my vertices and my co-vertices. That's not the best. If this will work better. That's a little bit better, not much. So now we have our box, right? So then we know that our asymptotes go through the center and the corner of my box. So I'm going to draw on those asymptotes. And I go from the center here and through the corner of this box here, and then this way. So those give me the asymptotes. Remember, those are the lines that are going to contain my curve or help my curve like actually shape the curve. So my A value is an X, right? So that means that this is my vertice. Your hyperbola has to go through your vertice. So here's my vertice. So that means that is the vertex of my hyperbola. So my hyperbola is going to go out this direction, right, and go this way. And then it's going to go curve this way, hug this line over here. It's going to go towards those asymptotes, but not actually cross them. So then over here again, you're going to go towards there, right, but not cross, and down this way. So there's your graph. To find the focus is a little bit different for a hyperbola. It's c squared equals a squared plus b squared. So that means it's going to be c squared equals 25 plus 16. So c squared equals 41. So c equals the square root of 41. So we know the square root of 41 is greater than 6 but less than 7, right? Because it's between 36 and 49. So it is approximately 6.4. So then I know I would add that to the center of my hyperbola, right? So it's going to lie on your major axes, and it has to lie inside of this graph. It has to lie inside the hyperbola. So it's like this is a bowl, and it contains the focus. Like it has to stay inside the bowl, right? The hyperbola. It has to stay inside the bowl. So I'm going to add and subtract 6.4 to the x coordinate of my vertex. So 2 plus 6.4 is 8.4, comma negative 1. And then 2 minus 6.4 is negative 4.4, comma negative 1. So let's see here. If I went negative 4 units, so there's 3, there's 4, so 4.6, so there's my focus on this side. And then I should go so I can go over 8.4, so 8.4, sure enough, down 1. So therefore I can see that my focus is inside both. So that shows me that I've got all of these things correct. And that is the end. If you have any more questions, feel free to send me a question through Remind. I will be more than happy to help you. Have a good weekend.